Hello, my name is Avi Kantha, and today I will be discussing my Lab 1, constant velocity in Physics 2211. So let's talk about a little bit about my introduction. So this lab aims to compare the observed motion of an object, which in my case is a ping pong ball that is moving at constant velocity in the positive horizontal direction, to the predicted motion of the same object using a model made from code. The object that will be observed is a ping pong ball, and the observed motion will be seen using tracker, and the predicted motion will be seen using glow script. This lab will help us understand Newton's second law in detail, which states that the velocity of an object changes when an external force is applied, or in an equation, the net force is equal to mass times acceleration. The system in this case will be the ping pong ball, and the surroundings will be everything else. It can range from the sun to even the table that's right underneath it. So Newton's second law of motion. As stated earlier, it's an equation that is F net equals mass times acceleration. However, the equation can be manipulated by changing the acceleration to change in velocity over change in time. We can manipulate this equation to become final velocity is equal to initial velocity plus net force over mass times the change in time, which is also known as the velocity update formula. Another important formula is the position update formula, which is the final position is equal to the initial position plus velocity average times the change in time. And this is a little preview of the graphs I'll be discussing. And this is a video of my ping pong ball, but it is not working, so I'll show it like in little increments. So yeah. So this is the observed position in tracker. So what I did in tracker is first I inserted and set the video length, and then I inserted my axes to where the starting position of the ball is, so I could get it at 0, 0. And then I inserted my calibration stick, so it understands the video's length and how big every single part is. And then I plotted points at different intervals, observed it on the table and on the graph. And the tracker findings was that my initial time was, of course, 0. And then my time intervals was 1/30 a second, as I did it frame by frame. My final time was 1.3 seconds, as that was the final frame. My initial position is this number right here, which I found through plotting it on the thing. And my initial velocity is 0.35. And this is done by subtracting the position of the second interval with the first interval and dividing it by the time between those two intervals, which would be 1/30th of a second, as it is only one interval. And all these findings were very necessary to create a glow script model. So this is my glow script code right here. So right here is my initial velocity vector, and I did this using the findings from the last slide. This is my initial time and the change in time. So initial time is 0 and change in time is 1/30th of a second. Right here is my final time. So we are changing how everything moves, and we need to make sure that it stops at the final time at 1.3 seconds. This is the rate which I got from from my tracker. It was I left it as 100 because there's no need to change that. My Fnet, I decided to keep it 0 because we're assuming it's constant velocity, which means no acceleration, which means no net force. And these two are so this is my velocity, the change in velocity formula. So I'm using the velocity update formula, and I'm using the position update formula here. So that's why those two were useful to talk about earlier, so that now I can see how it changes per interval. So now this is the graph that I got from doing that. I got, so as you can see, the position, the x direction is linear, constant, and is linear and constant. And just for reference, my velocity, as you can see, is constant at 0. So now I put everything into an Excel spreadsheet and the data into an Excel spreadsheet, and I graph two lines. And those two lines, as you can see, the green line is my predicted position, and the orange line is my observed position. The green line, for whatever reason, is a little bit goes a little bit further, or the predicted position goes a little bit further than the observed position. So some possible errors of this could be some outside forces such as friction or air resistance in my observed video that could have slowed the ping pong ball, or slight errors in measurements in tracker, which would, of course, is some human errors and will lead to slightly inaccurate results. So what if I analyze my video in tracker? So if I decided to change the positive x and negative x, and if that happened, nothing will really change. That would just change my direction on the slope to negative, and however the magnitude of the values would remain the same, so I would be able to interpret it the exact same. And what does it mean? So basically here I'm asking if I can figure out how many forces or how many pushes and pulls are on my on the ball, and to give it a net force of 0. And honestly, it's not possible to say, because there may be 100 to even maybe 1,000 different forces, as all the surroundings like all the surroundings affect the ball. And thank you to for listening to my presentation on my lab 1 constant velocity.